The year is 7960, and we're 350 years into the first manned mission to interstellar space. The sole remaining crew. He's perfectly healthy physically, but he's utterly insane. Terminaled in God knows where. It's like lucid dreaming, to dream within dreams to enter deeper into the dream world. There is no way to talk seriously about interstellar travel. The probability of interstellar travel starting 5,000 years from now, according to some particular set of assumptions, is close to zero. But it isn't exactly zero, and I'm going to talk about some non-zero probability themes. Big innovation event. One of the things I mentioned in the previous video was how there are these cycles of progress. There is a golden age followed by dark age. Dark age is triggered by catastrophes or bottlenecks. Golden age triggered by discoveries or innovations. So copper smelting triggers the Bronze Age. Iron smelting triggers the Iron Age. And then steam power triggers the Industrial Age, etc. It's pretty coarse grain, but it's just a convenient way to categorize periods of time. And I had this situation after 540 hours in Factorio, so year 7200 according to my time conversion, where I felt this steep drop in motivation. I felt like I was inside this long dark age. The next obvious thing to do is to plan for interstellar travel, but instead I'm just stuck in this time loop of boring chores. Every single outpost has something missing. This one has a shortage of water. I look into this facility that stores water ice. I discover that there is a way to shrink water as in volume by a factor of 100. This water cistern infrastructure that I was working on just before can be immediately dismantled. We're talking monumental industrial changes here. The 5,000-year innovation. The magnitude of this innovation is of the type that makes interstellar travel possible. Theoretically, the rocket could have been built without it, but there's just this problem that here is Saturn V, so the rocket that got us to the moon, and Artemis, and Starship. And here's Empire State Building. Humanity's first interstellar spaceship. The asterisk is there because there will always be a bunch of small probes, etc. So Voyager is like the first. And then there are these ideas like solar sail that aren't capable of braking to actually stop at the destination. And they don't count. This is the first serious mission. I am not a rocket scientist, and there have been a number of eye-opening moments when I was studying the basic mechanism of this that I want to share. The first is that this is a small spaceship, assuming the trip takes 400 years using nuclear thermal and nuclear electric technology that we have today with upgrades, mainly relating to sizing power plants up to how big they need to be. Without upgrades, this spaceship could be 10 times larger than this, so 50 kilometers. Why is that? There is this thing called the tyranny of the rocket equation. Almost all that this spaceship carries is propellant, like water. Essentially the way any rocket moves forward is by throwing stuff out the back. That's propellant. And there is this misunderstanding that, oh, since there isn't any friction in space, we can just keep pressing the gas pedal and the car will just go faster and faster. That's not how this works. The propellant needed to keep accelerating increases exponentially. And we need to keep accelerating a lot to reach the speed needed to be able to reach our closest stars in 400 years. The speed needed is 3,000 kilometers a second, and that's another eye-opener how fast that actually is. Here's how fast Voyager 2 is going, and here's the 3,000 kilometers a second spaceship. I was also thinking surely this rocket would be built in orbit to make sure we don't have to launch the rocket into space. And we could also speed it up using a Jupiter gravity slingshot like Voyager. But Earth gravity and Jupiter slingshot are non-factors. They would help reduce the amount of fuel needed by less than 0.1%. To go into orbit, you need a speed of like 10 kilometers a second. 3,000 kilometers a second is fast. But the spaceship would still probably be built in orbit, because just imagine the dust cloud from this. Launching this thing from Earth would be like a mass extinction event. Another eye-opener is that while this spaceship carries insane amounts of propellant, this spaceship right here, which is also a nuclear electric one, but slightly upgraded from this one, is a more reasonable 1 kilometer long. and it only carries 10% propellant. How is that possible? To explain why, I want to show you this great GIF that basically explains the rocket equation. There's this guy on a boat with a pile of rocks, and as he throws them off one by one, the boat gets lighter and starts going faster. So what this transition means, going from a 5 kilometer to a 1 kilometer spaceship, in this example, is that if we add some muscles to this guy, he will throw the rocks off at a higher speed, and it turns out that if we just add a little bit of muscle, we can reduce the pile of rocks by a significant amount. So basically on both these spaceships we have muscles, power plants that decide how fast the fuel goes out the back. That's the rocks. And here we managed to improve the power plants, and that's why we no longer need nearly as much fuel. The question is how difficult it will be to do this power plant upgrade. The specific transition I'm talking about is how to go from standard ion engines in use today, in Starlink satellites for example, to what is known as VASIMR, Variable Specific Impulse Magnetoplasma Rocket. As with a bunch of other technologies I'm not talking about here, like fusion, antimatter engines, or exploding plutonium bombs to push the spaceship forward, VASIMR is untested for the enormous scale of things shown here. So going back to this 100-to-1 water compression idea from Factorio SC, it's a good one because while we don't know what the actual engine tech will end up being, it's this very crude sum up of the magnitude needed to make this transition possible. Either we need big innovation in engine tech or some way to compress propellant. Otherwise we're stuck with these enormous spaceships. Who drives it? Would humans be on this type of spaceship for a 400-year trip that starts 5,000 years from now? It's pretty likely because of our adaptability and problem-solving skills. But there are many questions. What is the number of humans that would be on the spaceship? Can we really be sure that there won't be any violence over 400 years? We cannot be sure. We haven't done the type and scale of experimentation that would allow us to answer questions like that. We have a bunch of small science experiments running at our current space stations, and the Russians did the Mars 500 experiment, where 6 dudes had to live in this container for 520 days. It went great, but it leaves a few questions unanswered when it's 400 years. We have done multi-generational experiments on mice, where the results aren't that great looking. Crazy scientist John Calhoun in 1970 built this enclosure called Mouse Utopia. The complex is like 4 meters in diameter and built such that there are these apartment building looking nests on the walls around a central square. There's unlimited food and water stored in these containers. And then he put a few mice in there and left them to do their own thing and reproduce. 2 years later, what do you think it looks like? Pause the video if they're all dead. What happened? So here's what happened. The mice first reproduced to the point of severe overcrowding over a couple of generations. Then, after 560 days, one can start distinguishing between 2 categories of mice. The first category are the Lord of the Fireflies ones, the ones that still behave normally and want to reproduce. And their territorial aggression and competition turns more chaotic and extreme with each generation.
And they are bitten up, and the one who is bitten fails to run away.
We can say it's horrible, but it can still be considered natural behavior. More interesting is the emergence of the second category of mice, the antisocial ones.
And this is one of the types of lack of involvement, of total withdrawal from the reality of the environment.
Even though mice of the second category never reproduce, more and more of the offspring of the Lord of the Fireflies category become antisocial. Why? Because it's an overcrowded, confined environment. Nearing the end of the experiment, Calhoun looks over the enclosure and says,
Now, it's between 2,200 and 2,500 mice, that is bodies, moving bodies, but there are really only about 150 mice in here. Real mice, that is mice who are in the social swim. All the others have been rejected in one way or another.
Many of them have ended up in the middle square. There they sit and do nothing. Some of the alpha males of this group are total narcissists. Calhoun calls them the beautiful ones. The only thing they seem interested in is grooming. It's tempting to draw parallels to humans. This excessive grooming is like being one of those socially awkward gym bros. in human terminology, trying to make oneself as fit and attractive as possible in one regard, while being completely unfit in another, by, in this case, total ineptness at basic social interaction.
Previous study shows that they are unstressed. They're just not here insofar as involvement.
That you started this experiment.
The number of antisocial ones finally reaches a critical point, and the population starts collapsing. Baby mice are abandoned and die within days. The speed of the collapse is perhaps the craziest part about the whole experiment. After a couple of months after the population peak, with thousands of mice, the last mouse dies out. All the mice at the end were so mentally broken that they'd lost any will to do anything. Could the same thing happen to a human spaceship crew? The spaceship is launched with a crew of 7, fertile males and females, and we have a cargo of human sperm and egg that can be used for artificial insemination, and incubators for babies that one day will have to take over as the second generation crew. How would we raise this next generation? There isn't much space. There'd be toys, maybe a small playroom, and an infinite number of videos to watch, all the premium accounts unlocked. But one day, we have this situation where teenage boys are running around and fighting. We'd be good parents, force them to shake hands and sit down and talk about how bored they are. We can be fairly certain things would be okay for at least 1, maybe 2 generations. But 5 generations? In order to put the problem into perspective, humans choose to organize themselves according to something that looks like this. The 1% of the population controls 99% of resources. It's a core idea of Darwinism, winner takes all. And the same way for this crew. After some generations, they could very well be organized like this, where one crew member controls everything and everybody else is kept out in one way or another. And on the opposite end here is a crew member who is a dispossessed incel. He's not happy about how things have turned out, and he doesn't give a damn about anything. The only safe human is a sleeping human. In this scenario, machines operate the ship, and 30 years before arrival, they combine cryopreserved eggs and sperm and start growing this guy in an incubator. But it doesn't work very well. The ship's supercomputer has been very patient with this man. Finally, Code Yellow is triggered, a mechanism where he is deemed unfit and loses access to mission-critical infrastructure. Doors are locked, one after another, until he's locked into this fake cockpit. Bikura? For a manned mission, you could assume the humans selected for the crew will be the smartest, when in fact they may be specifically picked because of how stupid they are. In Hyperion by Dan Simmons, there is this the only safe human is a Bikura human idea. The Bikura are these lobotomized bald people living in the jungle, in some village near a cliff where they fall down sometimes. They all wear the same clothes, they all look the same, they don't have any genders, so no sexual organs. And when they die, they resurrect with slightly less IQ than last time. So, it's sci-fi, but it gives an insight into what humans could have been like if they were part of the fauna of asexually reproducing species, like some lizards and sponges are today. And they have certain evolutionary advantages in their environment. Another take on this is more optimistic, in a weird sense. I heard it from Mikhail Khodorkovsky, the Russian oligarch who's turned into a bit of a philosopher, and Star Trek. Basically that violence and war just won't be a thing in future technologically advanced society. Khodorkovsky said it in the context of the Gen Z Alpha TikTok generation. This generation is totally harmless, constantly on their phones watching crap. Power for them seems to be about number of views or followers. In other words, for whatever reason, the humans are themselves evolving into Bikura, so there won't be anything to worry about. It also reminds of Foucault in the sense that these TikTok humans still have just as much ego and power hunger, but they try to get it by trying to kidnap people's attention instead of using violence.